Hello everyone. Today our group will be presenting our project. Our project is on building a crawler for reality houses, reality sites in Boston. So in Boston, there are a lot of different websites and web pages, and a lot of different agents are handling them. And there is no unified portal where you can see all the job house listings. So when we were thinking about the housing problem in Boston, we thought that we could make a unified platform where we can crawl all the listing data from different websites and make a dashboard to show it together in a single place. And this would be very convenient for the people who are looking for houses. So this was the inspiration for our project. So the objectives of this project were we basically want to develop an efficient crawler which can pull data from different websites. After pulling this data, we want to structure it and store it in a place. So we decided to implement this with Python using Beautiful Soup, which is a web crawling library. And we stored this in a SQLite database for testing. And when we went for deployment, we stored this on Databricks. And lastly, to show the insights and show the listing in real time, we decided to go with Tableau. So our Tableau dashboard updates every day, and it'll show the amount of listings based on different locations, the number of beds, who the broker is. So when people are looking for a specific place, they can just put filters and find the place instead of going through a bunch of different websites and find a house. So in the end, this will allow the users to like get a comprehensive overview of the housing situation in Boston. And in the end, we can also like show some trends which will allow them to book a house when it's cheapest. Moving to the next slide. So we chose this topic because this topic is something which affected us particularly when we moved to Boston. Only two cities had rent grow faster than Boston in between 2021 and 2022. And since Boston is largely dominated by students, we thought that this would help students a lot because students, as it says, they don't have a high range of income, so they are not eligible for a lot of housing. And lastly, we wanted to like provide a tool which is very simple for people to use. We didn't want to develop a tool which has a steep learning curve, and I think a Tableau dashboard is probably the easiest way to implement that. Moving to the next slide. Yeah, Achyut will take over from here.
Yeah, thanks, Karan. So, hi everyone. I'm going to be talking a little bit about the methodology of our project. So, on a high level, we have four main functions. First, being the web crawling and the data scraping part, where we'll be basically visiting websites and extracting information from each website on a breadth first search basis, which I'll be talking a little bit more about. Second step is the transformation and storage, where we will be getting the unstructured, untidy data, which we will transform, and in the end, store it in a format which we will be, which will be useful for us in the next stage. And that would be the data visualization part, where we will be looking at our clean data in a way that would be useful for end users with a lot of graphs and charts and everything else. So in the end, we are also deploying our entire project so that it is automatically updating and we don't really have to perform some manual task of running the program or refreshing the charts. So all of that will be automated and ready to go for the end user. Next slide, please. So, talking about web crawling and data scraping, we have a few sites which we are going to be scraping data from. That is Boston Pads, Zillow, Hotpads, and YouGot listings. So these are the popular websites among graduate and undergraduate students who compose the majority of population of Boston. So using these websites, we will be gathering the HTML data through the method of web scraping. And how we're going to do this is going layer by layer, website by website. So this is the breadth first search approach that I was talking about. Um, because the websites have so many links and so many different elements to extract from, we will have to be really methodical and efficient in how we would scrape our data. And for this particular reason, I believe that breadth first search was the most efficient of the options that we had. Um, Basically, here we will be visiting the links one after the other on the first level and going back to the root and visiting the next level of links. And the last stage of this would be to store all of this scraped information in a format that would be usable. That would be CSV, JSON, etc. Next slide, please. Coming to data transformation and storage, as you can see on my left-hand side, this is the data that we will be looking at initially, the untidy data that is really not usable with tons of HTML tags and a lot of key value information on the bottom left-hand side. So we will be essentially using the Python package Beautiful Soup that is the one of the most popular packages that is used for data scraping from the World Wide Web. So the end result, what you see on the right side, is the cleaned data set that is stored on SQLite, which I will be talking about next, with all the fields necessary, like the last updated of the listing, the price, number of beds and baths, excuse me, the location, and we have few more fields which I wasn't able to put it on the slide. Yeah, next slide, please. And the database of our choice was SQLite. Why? Because it is a lightweight serverless database, which means that it does not really require any additional database engines, or it does not need any server to run. And it is also embedded as a part of the Python package. It has really good performance for small to moderate size data, which is exactly what we are dealing with in the Boston housing, because at a time at most we will have around 5,000 to 6,000 listings online, and that data is small enough for the SQLite database to store efficiently, and the read write will be really fast. Lastly, there are no dependencies, which means that we don't really have to install any kind of software or any additional overheads for it to run. All you need is Python, and you need to install the package for that. That's simple. Yeah, thank you. Next slide. I'm going to be moving forward with Shashank.
Yeah, thank you, Achyut. So yeah, as Achyut had explained about SQLite, it is a brilliant database tool. But we want to connect this SQLite database to our Tableau environment. So natively, Tableau does not support SQLite. So to actually be able to connect our database to the Tableau environment for getting our visualizations, we will be having to first of all install a custom driver which was made for SQLite for Tableau. This driver uses the Microsoft Open Database Connectivity Interface, or the ODBC, as its main connecting component. So once we have installed our SQLite driver, we are easily able to connect our database that has been generated through the Python code into our Tableau environment. And after we do this, we have to ensure we make one more change in the server settings, which is to ensure that we have a live connection between the database and our Tableau server. The main reason for this live connection is so that whenever the database changes on the backend, we want to make sure our tables are also updated at the same time. So yeah, next slide. Yeah, so this is a small example of what our ODBC SQLite driver looks like, which the custom driver we have used for connecting our database to Tableau. Next slide, please. Now on to the actual database on the visualization aspect of things. So Tableau is a very powerful data analytics tool and a visualization tool, and it is used across the world for business analytics. So we have used it in our project here to create several easy to use and interactive dashboards. These dashboards can be used for multiple purposes, such as filtering, searching, and also analytics. So first of all, we have created a dashboard where we have combined the data from all websites that we have scraped into a single location. And here you scrape, you can search and filter through listings to find exactly what you're looking for. Furthermore, we can also use the analytics tools that we have developed to identify trends within the rental data and trends within the housing market. This helps us analyze and enables us to make more informed decisions on our rental houses. So this is the dashboard I was talking about, where we can search and filter our data, the listing data that is combined from several sites. I will be explaining more about these dashboards in the live demonstration. Next slide, please. Same here. This is our analytics dashboard, and that is going to be explained further. Yeah, Karan, you can continue. Thank you.
Yeah, so for deployment, we decided to go with a tool called Databricks. Databricks is a unified data handling, management, and storage platform, and it also provides the analytics tools needed for data analytics on the same platform. So I will be sharing Databricks shortly. Just it'll take a moment to load. Yeah, is my screen visible? Hello?
Yes, it's visible,
Yeah.
Karan.
Yeah. So here we can see Databricks is basically a Jupyter notebook which is running on Spark. Spark is a distributed computing like interface. So we are just installing the packages needed here, and from here on we'll start structuring our tables and start the web scraping. Again, this for different websites you have put different conditions and scraping conditions, and most of this is being done by regular expressions and just loading them using beautiful soap library. So the main advantage of using Databricks is we get to schedule the tasks as we want. So this task, for in this case, we have been planning to like schedule a task that runs almost every morning, and it'll run for like 30 minutes. And the new data for every day will be loaded into the database, and that will be connected to Tableau. And every day you can like get a new updated dashboard, which has all the latest listings and changes. And one more advantage of using Databricks is it is natively connected to Tableau. And in this case, I've been running this job and it's been running for like 20 minutes. So whatever data it's pulling, it'll be stored and updated in real time. And this is a sample of the data that we already have. I loaded up to 1,000 rows here, but the one that will be showing, we already loaded data on a previous run, and it'll have around 5,000 listings. I'll stop sharing, and Shashank will now show the Tableau dashboard which is connected to the data.
Thank you, Karan. Let me just share my screen too.
Yeah, we can
Yeah,
see.
let me know if it's visible.
Yes.
Yeah, thank you. So yeah, as Karan had mentioned, Databricks is directly connected to Tableau from the pipeline. So here, what we're looking at is the online uh, Tableau platform that we have provided for users to use. So let me just run through the entire usage of this real quick. So as we can see, this is our landing page where we have a cumulative information database for all the listings that we have had from all the several websites you scraped. So you can scroll through them, or you can use all the filters that are provided on the left, such as area. So you can add areas that you want to select. If you wanted to only look at some particular areas that you wanted a rental house for, you can use this. Or you can just click on all to go through all of Boston. Uh, Additionally, you can filter based on beds, baths, and such. So where you can mention, I want a 5-bed and a 2-bath house, and it'll limit the searches to only within those criteria. And you can also change price the same way. Additionally, if I click on any listing, so let's say this listing in Alston, Boston, you can see all the rental details down here, which provides the price of the house, number of beds, baths, location, when was it last updated, the utilities that are mentioned on the listings, which includes like heat, hot water, electricity, whether these are paid by the tenant or by the landlord, and the amenities provided such as parking, laundry, air conditioning, etc. And additionally, one major benefit that we provide is providing the agent details. This is usually something that people struggle to find for the housings that they for the houses that they like, and we are providing these details too from scraping from several websites. Now on to our next dashboard. So our second dashboard here is going to be the analytics dashboard. Here, as we can see, let's go from the left. First, we have our price change month over month dashboard. So here we can see how price has changed over the period of several months for the listings that are coming up in Boston. So you can use this to find trends within how prices change. And as we expected, the prices have been going up towards August because usually students come in towards the September for the fall semester. So we can see a clear rise in the prices from June to August. Similarly, we have a availability histogram down here. This basically, this graph tells us the count of houses that are available to be occupied from that starting date. So as we notice here, as expected, most of the houses that are available for occupancy are around the August, September, and October times. This is usually because this is when most students move into Boston, as it's a student city, and it is where most leases end and begin. So as expected, most of the leases are beginning and ending around August and September. And lastly, we have a listings over time graph. So this graph basically shows us all about how many listings are available over a period of time. So as you can see, most listings that are available right now are from August itself. They have been generated in August compared to April, May, June, July listings that are all pretty much done with. So this means that every new listing that has come up has usually finished and has been the listing has been taken off the market as soon as within a week of the listing being posted. And as you can see, most of you don't have too many listings from older publications. So again, here you can use areas to filter. So you can only like you can unselect a few areas. You can maybe select exactly what you need, and it will give us the data for the same. And lastly, we have our listings today dashboard. So this dashboard is mainly for on a day-to-day basis, which you would just have a glance at. So this shows us all the listings that are currently available in every single area today. So if you wanted a house right now in Boston, you would be looking at this dashboard to see which area would have the listings that you require. So as you can see, Boston, the area Boston has 23 listings that are available right now for you to occupy, similar to South End and Dorchester. And as you click through different locations, you can see that it shows a price histogram for each of these locations. So you can make an informed decision on what the average price used to be in these areas and the prices and what the price is like for the listings you are looking at right now. So using this information, you can make a very informed decision on whether you are overpaying for your house or not. So this is our dashboard that we have currently created. And let me conclude by saying that this dashboard is going to be very crucial and is going to be very helpful for students or users in general for finding cheap and affordable housing in Boston. As Karan had mentioned previously, the prices are rising too much nowadays in Boston, and students really can't find affordable housing near their universities. So by using the analytics tools as well as the combined ease of use search dashboard that we have created, we hope that students will easily find the houses they require and succeed in their rental journeys. So that's our project. Thank you.
Thank you.
Thank you, everyone.